Okay, hi. So welcome to this video on the 2019 Paper 1 Junior Star Higher Level Question 9. Now this is a doozy of a question. So if you want the set of notes I'm working off, just send me an email at shanetroy@gmail.com. That email address will be in the description below. As with all the questions, I suggest having a go, okay, as you get to each part of the different parts of this question 9. Just have a think through yourself. This is a fairly tricky question, so each part feeds onto the next. So it's worth, before we get stuck in at all, pointing out that in the exams, if I gave an answer that well, it might be wrong, for example, in this part, that answer must be corrected accepted as correct in every part after that. Okay, you can't be penalised in part B for the wrong answer in part A. If you use the answer in part A as if it was correct and do things correctly in part B, you can achieve full marks. So that's something in our advantage. So let's read through this here. And it says that Gertie writes down the following sequence, which repeats every 3 terms. So you have the first term there is 3, then you get 6, and then 4. So then repeats 3, 6, 4. Now if you keep going, 3, 6, 4, 3, 6, 4, to infinity, whatever. Okay. So part A, part 1 says write down the value of the 12th term. Now, I've done the work there, okay, so this is the 3rd, then the 6th, the 9th, this is your 12th term. So the answer is 4. Okay, so part 2 then, now part 1 and 2 are marked together, so if you get one of the part correct, usually you'll get the 4 at that stage, the 4 marks. Part 2 then says work out the value of the 100th term in this sequence. Now, if you think, okay, every 3 it repeats, so how many of those repeats are in our 100? So it's basically 100 divided by 3. Okay, now that's going to give you 99 and 1 remainder. Okay, so it repeats 99 times. Now, on the next, once that's finished the 99th time, there's 1 movement left over. So if you think about it, dot, 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 as far as 99 is 3, 6, 4, and then the next one is back to 3. Okay, I know I kind of got off the screen there. So the value of the 100 term is 3. Now the answer is built in there. Okay, I'm just kind of trying to get that point across. And part B now. Okay, so it says describe how to find the value of the nth term in the sequence, where n is an element of n, so it's a natural number. So your n would be all positive whole numbers. And you're not allowed to list all the terms from first to nth, which technically you couldn't do because nth could be a billion or a trillion or whatever. So if I remember this, and I had a look at it before I started, but this is tricky. I don't know if I'd have gotten this personally, just unless I was fired on all cylinders. So basically, I'm going to use the answer here for simplicity. If we divide your fictional value by 3, we could get 3 things happening. The remainder of that number could be 0. Okay. In that case, your nth value is equal to the 3rd value. Okay. So in a sense, what we're talking about here is similar to doing this. So if I took my first value there and divided it by 3, okay, you get a remainder of 0. That would be this situation. Okay. If you divided this second term by 3, okay, actually scratch that, I'm going down a rabbit hole. So if I start here, okay, with this, I suppose I'll take this example here. Okay, if my 10th one and divide that by 3, that gives me, you see here, 3 with a remainder 1. So the 10th term will always be the situation where it's equal to the first, which is 3. Okay. Now, if I had 11 divided by 3, that would have would go in 3 times the remainder of 2. So that would be equal to the second term of your sequence, which is 6. Now, if I had 12 and divide that by 3, there is no remainder. Okay, it goes in 4 times, so no remainder. That's equal to the 3rd term, which is 4. Now, if you went again with 13 divided by 3, there'd be 4 times remainder 1. That would be same as the first sequence, it'd be 3. And then 14 divided by 3 would be remainder 2, would be 6 again. If I keep going that way, 6, and then 4. If you keep testing it, okay, it'll work. You're basically trying to say that test, okay, in language. It's hard, okay. Again, this is a tricky part. So it's only now you won't know that when you're doing the exam. There's only a small amount of marks. So if you can get anything for this, and you get 2 out of it, I'd be fairly happy. So this part C here, part C and D are marked together, and only worth 5. There's a lot of work going on here. But Gertie made her sequence 364, 364, 3, whatever, by picking 3 as the first term, and then using this rule. If a term is odd, you multiply it by 2 to get the next term. If the term is even, you add 2 to it and divide by 2, or multiply by half to get the next term. So every number is either odd or even. So they give an example there. They say if 3 is odd, the next term is 2 times that, so 2 times 3, which is 6. Now that's even, so that follows the second rule. So we're going to add 2 to it, so 6 plus 2, and they're dividing by 2, which is the same thing as multiplying by a half. So 6 plus 2 is 8. You do inside brackets first. 8 times a half is 4. And then that's even, so it'll generate another number. And you get a sequence that will do different things. So part C says a different sequence follows the same rule. That's important, which has 8 as the first term. So we're asked to work out the first 4 terms. So in this case, 8 is odd. So it follows, 8 is even. So it follows this rule. So it's a half times 8 plus 2. See, but doing the same brackets, 8 plus 2 is 10. 10 by a half is 5. So my second value there is 5. Now 5 is odd, so I'm asked to just multiply that by 2. That gets me 10. Now 10 is even, so it's a half times 10 plus 2, which is the same thing as a half times 6, which is, half times 12, which is 6. Now 6 is even, so you're adding 2 to it to get 8, dividing that by 2 to get 4. So that sequence will repeat, and we basically have our first 4 terms, right there. And let's just try to show it. Now part D then says, Ahmed takes 2 as his first term and makes a sequence using the same rule. State what is unusual about Ahmed's sequence. It might be useful to work out some of the terms of his sequence. So if I take the first term, which is 2, that's an even number, so I'm told to add 2 to it, and then multiply by a half. So 2 plus 2 is 4, multiply by a half gives you 2. Now, if that becomes my second term, I'm going to do what it says by the rule. The second term there is now, we know it's an even number. So with an even number, you add 2 to it, and multiply by a half. So you get 2 plus 2 is 4, by a half is 2. So you see, if I keep going, my third term is going to give an answer of 2. So it's the fourth term, fifth term. It's going to repeat forever. So that's unusual. That's the answer. So that's part C. Now part E here says, in another sequence using the same rule, the second terms are 86. Work out the 2 different values that the first term could have been in the sequence. So basically, this is tricky. But in the rule for odd, you're told to multiply by 2. Now, what's, in a sense, the reverse of that? It's divide by 2. Now, at the even, you were told to multiply by a half and then add 2. So, whatever number, add 2. So, if I'm doing the reverse of that, I'm going to multiply by 2. And your number, you're going to take away 2. So once you realize that's what you're trying to do, you're trying to get what's the reverse of it, or what would have originally happened. We know it. We know that. What's the reverse of that? I don't know how best to say that. Here's the answer anyway. So if the first term is odd, it could be 80. It would have been multiplying by 2. So the reverse of that is to divide by 2. 86 divided by 2 is 43. Now, if the term would be even, the first term, you would have divided by 2 and added 2. Okay, so the reverse of that, the opposite of that is multiplying by 2 and taking 2. So 86 times 2 is 172, take away the 2 is 170. That's it. Now, part F is hard as well. It says a different sequence following the same rule starts with the number k. So we're looking at general here. And they say k is odd. Okay, so we know what we have to do. If it's odd, you're multiplying by 2. So the second term is k by 2, which is the same thing as 2k. Now, any number multiplied by 2 must be even. So think of it. 3 times 2 is 6. 3 is odd, but you multiply by 2, it turns into an even number. 7 is odd. Okay, 7 times 2 is 14. 14 is even. So that is a fact. It's just not something a lot of people might realize. Okay, might just not register with them. So if 2 times k is even, well, we're told that the rule says we add 2 to it and then divide by 2. So it's 2k plus 2. Now you do that first, and then you divide by 2, or multiply by half in this case. So you end up with the 2's cancel here, and the 2's cancel here. So you're left with k plus 1. Now, if k was odd, you were told at the beginning, if you add 1 to any odd number, it turns it even as well. So k plus 1 must be even. The rule for evens is you add 2 and you multiply by a half. So to do that, you get a half times k plus 3. 1 plus 2 is 3. Now, half times k plus 3 is the same thing as k plus 3 divided by 2. Okay, if you said a half times k plus 3, you wouldn't be wrong there either. It'd be fine. They do say in the simplest form. Okay, I'm not quite sure actually, to be honest, if that would have caused a penalty. And that's it. Now, this is the end of question 9, okay? So look, it's a fairly hard question. So look, in the case of that, get what you can and attempt every part. And don't forget that if you have a problem with this first part, but you know how to do the other parts, just make up an answer for the first part. If that's needed later on, the answer you generate from that wrong answer will be accepted as correct. That's a very useful thing, and is something in your benefit, in your favor. Thank you, and see you on question 10.